Hi, I am Arib. You are watching my YouTube channel. 220 kV grid station complete explanation. Introduction. Our 220 kV substation is a high-voltage electrical facility that plays a critical role in regional power transmission systems. It serves as a key interface between power generation plants and the downstream transmission and distribution networks. By stepping up or stepping down voltage levels and enabling secure control of high-voltage power flow, 220 kV substations ensure grid reliability, efficiency, and safety. As countries expand their power infrastructure to meet industrial growth, urbanization, and renewable energy integration, 220 kV substations are increasingly being deployed in national grids, industrial corridors, and interregional interconnectors. What is our 220 kV substation? Our 220 kV kV substation operates at a nominal voltage of 220,000 volts and is typically part of the high-voltage transmission grid. Its core function is to either step down voltage from higher levels, example, 400 kV, or step up voltage from lower levels, example, 132 kV or 110 kV, depending on the power flow direction. These substations are generally designed to connect power plants to transmission grids, interface regional grid zones, supply high-load consumers like heavy industries or data centers, receive bulk power for distribution to smaller substations. Main functions of R220 kV substation: voltage transformation, step up or step down voltage between different grid levels, power flow control, route electricity to desired feeders and zones, system protection, isolate faulty circuits to prevent cascading outages, grid balancing, manage load sharing between parallel networks, monitoring and automation, use SCADA and IDs for real-time diagnostics and control. Key components of R220 kV substation. Our 220 kV substation includes a variety of high-voltage equipment and support systems. Below is a detailed list of essential components. Power transformers. Voltage rating 220 by 132 kV, 220 by 66 kV, 220 by 33 kV, capacity 100 MVA to 315 MVA, cooling, on and on AF, all natural air forced, may include on-load tap changer, OLTC. Circuit breakers. Type SF6 gas insulated or vacuum, for lower voltage parts, function, interrupt fault currents during abnormal conditions, installed on incoming outgoing feeders and transformer base. Isolators, disconnect switches. Used for no-load isolation of equipment, available in single or double break design, may include earth switch for safety during maintenance. Current transformers, CTs. Function provides scaled-down current signals for metering and protection, typical ratio 1200/1A, 1500/1A. Voltage transformers, CVTs. Step-down high voltage for protective relays and meters, can also serve as carrier signal coupling devices in communication systems. Lightning arresters. Protect equipment from lightning strikes and switching surges, installed at line entries and near transformers. Bus bar system. Types: single bus, double bus, main, transfer bus and ring bus, conducts power between components within the substation, material copper or aluminum, often tubular or conductor-based. Control and relay panels. House digital relays, annunciators, meters, and SCADA I/O modules, located in the substation control room or prefabricated control buildings. Earthing system. ensures personnel safety and equipment protection. Grid design follows IEEE 80 or equivalent standards, includes earth mat, rods, conductors, and pits. SCADA system. Supervisory control and data acquisition system for remote monitoring, interfaces with all digital protective devices. IEDS enables real-time fault detection, load analysis, and remote control. Battery bank and chargers. Provides uninterrupted power for protection and control systems. Backup typically lasts 2 to 6 hours depending on load, usually 220 volts DC or 110 volts DC systems. Types of 220 kV substations. AIS, Air Insulated Substation. Equipment is installed outdoors and air is the primary insulation medium, easier to inspect and maintain, requires more space and is vulnerable to pollution and weather. GIS, Gas Insulated Substation. Equipment is housed in metal-enclosed SF6 gas compartments, compact, low maintenance, suitable for urban or harsh environments, higher upfront cost but lower long-term operating expenses. HIS Hybrid Insulated Substation. Combines features of AIS and GIS, optimizes space and cost, often used in retrofitting or partial upgrades. Layout of R220 kV substation. Our typical layout includes 2 or more incoming lines, 220 kV feeders, 2 to 4 power transformers, 220 by 132 or 220 by 66 kV, multiple outgoing feeders to lower voltage substations, bus bars arranged in double bus or breaker and a half schemes, transformer bays and line bays, control room building with SCADA and battery backup. Applications of 220 kV substations. 220 kV substations are widely used in interstate or interregional power transfer, bulk power evacuation from hydro, thermal, or solar plants, grid interconnection between transmission zones, powering industrial clusters or economic zones, high voltage integration of renewable energy plants, solar, wind, cross-border grid connectivity. Design considerations. When designing a 220 kV substation, engineers consider forecasted load demand and fault levels, geographic and environmental conditions, land availability, AIS versus GIS, future expansion possibilities, safety and accessibility, cyber security in SCADA-connected substations, advantages of 220 kV substations, efficient long-distance transmission, reduced power losses compared to lower voltages, high load capacity for industrial and utility networks. Enhanced grid stability with proper protection schemes, integration ready for smart grid and automation platforms. Challenges. High installation and equipment costs, need for skilled workforce and strict commissioning standards, environmental management, oil containment, SF6 handling, maintenance complexity in multi-bay configurations. Conclusion. Our 220 kV substation is a cornerstone of modern power infrastructure, providing efficient transmission, protection, and regulation of high-voltage power. Whether for national grid stability, renewable energy evacuation, or industrial supply, these substations offer unmatched capacity, scalability, and performance. With the rise of smart grids and demand for clean energy integration, future 220 kV substations will increasingly feature digital monitoring, GIS design, remote operation, and AI-powered predictive maintenance, making them smarter, safer, and more reliable than ever before.